welcome to section 6.2. Today we're going to continue talking about those rational equations, but instead of equations, we're just going to be looking at expressions. These are going to be complex fractions. Look how crazy this stuff is, okay? I hope that these don't keep you up all night like Britney Spears was, or thinking about someone. Hopefully you're not thinking about these complex fractions that much that you can't sleep, but today we're going to be talking about these craziness or expressions here, kind of fractions on steroids. But we're also going to get into rationalizing, which I'm pretty sure we've done before. We just might need a little bit of a refresher on that. Alright, so here is what we're going to do. I'm going to show you the standard way, the way some of us may think that we want to tackle this problem, and believe me, you can absolutely use this way if you're more comfortable with it. But I'm going to show you kind of my way, which is very similar to section 6.1 that we just covered, okay? So two different ways. You use whatever you are more comfortable with, but I'm going to show you how in the end they both work. Alright, so standard way. Normally when we're dealing with fractions, we want to get a common denominator. Well, if you take a look at the top piece of this fraction, okay, so we have these two fractions added together all over, or they're both being divided by these two fractions. If we just focus on the numerator up here, these two fractions have a common denominator of 4, so we can simply add the numerators to get u squared plus u over 4. Okay, so we keep that common denominator. Now if we were to look at or this denominator, okay, we have two fractions in this denominator. We need to get a common denominator, so we can simply multiply this first fraction by u and this second fraction by the 3's. That way we can get our common denominator. So we're left with a 4u plus 24, okay, that 8 times 3, and then we're all over the common denominator of 3u. So hopefully we're following along with that, just getting a common denominator like you're used to doing in Algebra 1 or even pre-algebra. But here's the tricky thing. We have this fraction divided by this one, so instead of dividing by a fraction, we could multiply, okay, take our first fraction and multiply by the reciprocal. In other words, flip this second fraction. So we get something like that. Alright, so if we were to multiply straight across the top, u squared times 3u would be 3u cubed, and then we would have a plus 3u squared, and all of that would be over the denominator of 16u plus 96. Okay, so this would be our final answer after we simplified all these crazy fractions in here, and we are left with one fraction in the end. But here's my way, okay? It's a little bit different. It's going to use kind of the ideas we did in the first section. So when you take a look at what we have here, okay, let's try to find those common factors that we did in the first section, the one we just did. So looking at all of our denominators in this case of our individual fractions, our common factors, well, the common number between a 4 and a 12, or 4 and a 3 would be a 12. And then we also have a factor of a u. But here's the difference, okay? In this piece, or in this section rather, we need to multiply the whole top by these common factors as well as the whole bottom by these common factors. Because even though we have these individual fractions going on, we still have the overall fraction as our problem. So if we do that, remember you can think about these as all over 1. 12 divided by 4 leaves us with a 3, but we still have that u squared, and we still have the u. Okay, so 12 divided by 4 gives us a 3, but we still have the u squared and a u, so we can write that there. And then when we go over here, we have 12 divided by 4 gives us a 3, but we still have a u, as well as this u. Okay, so we're kind of getting rid of the top part of our fraction by just multiplying by those common factors. But let's do the same thing in the denominator. We have 12 divided by 3 is 4, but we still have this 4, and we're going to have our u. And then if we take a look at our second piece, the u's are going to cancel, so all we're left with is an 8 times 12. So if we simplify all this, we get 3u cubed plus 3u squared all over 16u plus 96. So notice how they match, okay? It's the exact same process. It just depends which way you're more comfortable. If you truly understand the idea of fractions and how you get a common denominator and you can multiply by the reciprocal, maybe this is your way of doing it. Or you can use the ideas that we did in 6.1, finding those common factors and just multiplying by those factors to get rid of your fractions to help you with this one. I'm going to tell you right now, this is the way I'm going to be doing it in the lesson just because I'm more comfortable with this method. But if you want to try this one throughout the lesson and check your answers with mine, you can absolutely do that. Alright, so let's check out another example. Let's take our original problem and we want to multiply by the common factors that all of our denominators have. So these, maybe I'll circle them, are our denominators. 5 and 4 have a common denominator or a common factor of 20, so I'll write that. Remember what we do to the top, we got to do to the bottom, because we do have an overall fraction in this case, so we're going to multiply by 20 on the top and the bottom. Now down here, x squared and x, they both have a common factor of x squared. Okay, notice how this is the bigger number. It's almost like if we had a 4 and a 16, they would both have a common factor, or the greatest common factor would be 16. So we can put that there. Alright, now multiplying across, let's see what we get. We have our first numerator is 1. Now, if we do our multiplications of our factors, 20 divided by 5, we are left over with a 4. And this x squared did not cancel out with anything, so we still have that. And we're going to subtract 3. Now, 20 divided by 4 gives us a 5 left over, and this x squared did not cancel out with anything, so we still have that. Okay, so that's just our first numerator, our two fractions up there. We're going to do the same thing down here. So our numerator is 16. 20 does not cancel out with anything on the bottom, so we still need that. But the x squareds do cancel out, so we don't have any variables left over. Our numerator is 5. The 20 does not cancel out with anything, so we still have the 20. And an x squared and an x, we're going to have an x cancel out, but we still have one left over. So we need that there. Alright, so multiplying through, we have a 4x squared minus 15x squared up top. And in the denominator, we're going to have a 320 plus 100x. But we can combine some like terms up top. We're going to have a negative 11x squared all over 320 plus 100x. And there we go. Okay, so we tackled our first complex fraction. We have fractions all over the place, but again, using the same ideas as what we did in 6.1, we can simplify these complex fractions into one reduced fraction. Alright, so let's give this one a shot. Finding our common factors for our denominators. I'm going to go ahead and circle those just so I know where I'm looking. This one's pretty simple. 9 and 9, they're the same number, so we don't have to worry about finding a multiple or anything like that. And then these share that m plus 4, so we don't have to, we only have one factor with some variables in it. Alright, so our first numerator is 2. The 9 is not going to cancel out with anything down here, so we still have that. But the m plus 4s will cancel, so we don't have any variables left over. Our next numerator is 2m. The 9s will cancel out, but the m plus 4 does not have anything to cancel out with, so we'll leave that there. Now, moving on to our denominators, our numerator is m. The 9s will cancel out, but we're left with an m plus 4. And then our next fraction has a numerator of 4. The 9 will not cancel out with anything, but the m plus 4s will. So when we start to simplify, we have 18 minus 2m squared minus 8m. And in the denominator, we have m squared plus 4m minus 36. Now what you could do if you wanted to is just rearrange the numerator. Maybe you want to put it in standard form. Or negative 2m squared minus 8m plus 18 all over m squared plus 4m minus 36. Now some of you might be kind of itching, I guess you could say, to factor this, what's going on here. But I'm going to tell you right now, these are not factorable, or they might be factorable, but they're not going to be able to cancel anything out once you factor them, specifically because of the way we multiplied by these factors. Okay, we're canceling out the common factors in the very beginning up here. Okay, we're canceling out the common 9s if we could. We're canceling out the n+4s if we could. So instead of waiting to the end to cancel out common factors, we're doing that at the very beginning. So don't worry about factoring this down here. Okay, you can if you want, but you're going to find that nothing else is going to be able to be canceled out. Alright, so what I want you to do is pause the video and try this one on your own. Give it a shot. Alright, let's see how I did. Finding the common factors of our denominators. Again, you can think about these 1s as over 1. The only really common factor we have right here is an x plus 1 that shows up. We could put the 1s out here if you wanted to, but multiplying by 1 doesn't really change anything. So when we go through and multiply by these factors in our top numerator and our bottom denominator, the x plus 1s are going to cancel out in our first fraction, so all we're left with is the x. But the x plus 1 does not cancel out with anything in our second fraction, so we still have that x plus 1 when we multiply it by that 1. Same thing in the denominator, the x plus 1s are going to cancel, so all we're left with is an x, but it's not going to cancel in our second fraction, so we still have it. When we start to distribute, combine some like terms, we're left with 2x plus 1 over -1. Okay, if you left it like this, that's okay. But some of you might actually go through and do the division by the -1. 2x divided by -1 is just -2x, but 1 divided by -1 is just a -1. So either way would work out in my book. Alright, let's just try one more. We want to find our common factors for our denominators. I'm going to go ahead and circle those. Okay, so we don't really have to worry about the 1, but in terms of numbers, we're dealing with a value of 4. For our variables, we have an x, and we also have an x minus 5. Alright, so let's go through and see what we get. Our first numerator is a 2. The 4 is not going to cancel out with anything, so we still have that. The x is not going to cancel out with anything, so we still have that. But the x minus 5s would cancel. So moving on, we have a numerator of 3. The 4 is not going to cancel out with anything. The x is not going to cancel out with anything, and neither is the x minus 5. So we still have everything left in that case. Moving on to the denominator, our numerator is x. The 4s will cancel, but we still have the x and we still have the x minus 5 as our factors. And lastly, our numerator is a -3, or in other words, we're subtracting. The 4 is not going to cancel. The x will, but we're also left with an x minus 5. Alright, so let's do some multiplication here. We have an 8x plus, okay, so the first thing I'm going to do is 3 times 4 times x, which is a 12x. Moving on to the denominator, x times x gives me an x squared. And down here, I'm going to be left with a -12 and then an x minus 5. Alright, so let's keep going. We have an 8x, 12x times x is 12x squared, and then we're left with a minus 60x. In the denominator, we have x cubed minus 5x squared minus 12x plus 60. And lastly, trying to maneuver some things around, combining some like terms. 12x squared up top, but we have an 8x and a -60x, so that's -52x. And in the denominator, doesn't look like anything's going to combine, so we're just going to leave everything the same. And there is our simplified complex fraction. Alright, moving on to complex rationalizing. This is going to be dealing with square roots in this case when we are dealing specifically with a fraction. And some of you might remember back in Algebra 1 or maybe Algebra 2 when you were dealing with square roots in fractions, like as an example 1 over the square root of 3. It is not I would say, customary or acceptable to have a square root in the denominator of your fraction. So in order to move it or get rid of it, we could multiply by the square root of 3 over the square root of 3. This is just like a tricky form of 1. Okay, square root of 3 divided by square root of 3 is 1. So multiplying by 1 doesn't really change the value of this. It's just going to change the way it looks. So if we were to multiply our fractions, we would have the square root of 3 over the square root of 9, but we know the square root of 9 is just 3. All right, so notice how we moved, or we got rid of the square root in the denominator, and we were able to move it to the top, and we no longer have a square root in the denominator. This value, 1 over the square root of 3, and this value have the same decimal representation. If you were to actually check it on your calculator, they should have the same decimals, but this is just a more acceptable way of writing it. So that's what we're going to do in this case. Okay, we don't want to have this square root of x in the denominator. We want to somehow move it to the top, but this one's a little bit trickier because there is this extra piece. Okay, it's not just the square root of 3 or the square root of x. We have this addition of 4 in this case. And what we're going to do in order to move the square root of x to the top, we're going to multiply by a form of 1, okay, just like we did here. But we're specifically going to use the conjugate of this denominator as our form of 1. Okay, so a conjugate, you might remember these back in the last unit when we talked about imaginary conjugates. If we have a 4 plus the square root of x, the conjugate is when we simply change the operation. We would have a 4 minus the square root of x. So that's what we're going to multiply on the top and the bottom. This is going to be our kind of tricky or special form of 1 in this example. So when we're multiplying fractions, we multiply straight across the top and the bottom. Now on the top, let's just keep these factors separate. We're going to take this x plus 3 and multiply it by this 4 minus square root of x. Okay, you can keep them like that. Don't worry about distributing. Okay, you can if you want to, but don't worry about that just yet. What we are going to do though is multiply or distribute in the denominator. So we have 4 times 4, which would give us 16, and then 4 times negative square root of x is negative 4 square root of x. Square root of x times 4 is a positive 4 square root of x. And then a square root of x times negative square root of x is a negative square root of x squared. Okay, we're multiplying by itself twice. So if we were to start to simplify this, at least in the denominator's respect, we would have 16. Notice how the negative 4 square root of x and the positive 4 square root of x actually cancel each other out. So maybe I'll show that here. They cancel each other out. And then we're left with the square root of x squared, but the square root and the squared cancel each other out. So we're just left with a minus x. So there is our simplified answer. Okay, you could multiply or distribute the top. Okay, if you wanted to do x times 4 to get 4x, and then we have a negative x square root of x plus 12 minus 3 square root of x. Okay, if you wanted to multiply, you could do that, but there really is no added benefit to doing this. Notice how we can't really combine any more like terms. So if you want to simply leave your answer in factored form in the numerator, that's completely okay with me. But we do need to simplify the denominator because we don't want that square root there anymore. And notice how we got rid of it. Okay, so we're completely done with rationalizing this complex fraction. All right, let's try another one just for practice. Since we have a square root in the denominator, we want to multiply by the conjugate. Remember, that's just when we change the operation between our square root and whatever else we have. So this would be the square root of x plus 2, and now it would be a plus 1. And to keep our fraction balanced, we need to do that or multiply by that on the top as well. Okay, this is our tricky form of 1. So now when we multiply our fractions, let's multiply our top. We can keep the 5 minus x and our square root of x plus 2 plus 1. But we do want to multiply the denominators because we want to get rid of the square root. All right, now let's be smart about this. Let's go back to the next one, or the previous one, sorry, and check out what happened here. Okay, notice how our middle two terms canceled out. Okay, that's going to happen every single time. So maybe there's a little shortcut we can use. Okay, you can absolutely go through and multiply if you want to. If you prefer to write every single step down, by all means do that. But take a look at what's going on. If these middle two terms are always going to cancel out, maybe we can automatically jump to our first term and our last term. Now this first term came from taking 4 times 4. Okay, 4 times 4 gave us 16. And this last term specifically came from taking this square root of x and multiplying it by this negative square root of x. So maybe we can use that shortcut if we want to. Okay, if you don't want to use that, by all means, don't use it. Okay, write out every single step. But there is that little shortcut since these two terms will cancel. So let's try that on this one. Okay, the first term comes from taking this square root of x plus 2 times this square root of x plus 2. So that would give us the square root of x plus 2 squared. But then our second term comes from multiplying -1 times +1, which would give us overall a -1. So if we start to simplify, we're not going to worry about the top because we're just focusing on the denominator. We don't want that square root in there anymore. The square root of x plus 2 squared, okay, the square root and the squared are going to cancel, so we're just left with x plus 2, but we still have that -1. So our final answer, we could say, is 5 minus x times the square root of x plus 2 plus 1 all over x plus 1. So notice how using that shortcut kind of takes up less work, less space, but make sure you use it correctly. Okay, again, if you want to write out every single step, do that just to make sure you check your work. Alright, let's just check out one more. We want to get rid of the square roots in our denominator, so we're going to multiply by the conjugate, which just change this to a plus instead of that minus. So if we got to multiply that on the bottom, we're going to do that on top as well. Alright, so multiplying across, we'll keep our numerators. No need to simplify those. We can have square roots in the numerator, but we cannot in the denominator. So let's use our little shortcut. We can take our first term times this first one, which would give us a square root of x squared. And then we have our second term times this second term. Now a negative times a positive is a negative. And then we have the square root of x plus 1 squared. Alright, so let's start to simplify. No worries about the top. Square root of x squared is just x. The square root of x plus 1 squared is just x minus 1, but we do need to distribute in the denominator. So if we do that, maybe I'll do that over here. The denominator is going to become x minus x plus 1. So all we're left with in the denominator, if these x's are going to cancel, is a positive 1. But anything over 1 is just itself. So all we really need to write is 2x plus 1 times the square root of x plus the square root of x plus 1. Alright, so what I want you to do is pause the video. It's your turn, and I want you to try these two on your own. Simplify this complex fraction. We got fractions all over the place. But on this one, I want you to rationalize this fraction, getting rid of the square roots in the denominator. So give those a shot, and I'll be back in a second. Alright, check it out and see how you did. For our first one, we want to multiply our top and our bottom by the common factors that we have in our denominators. So those would be the 2u plus 5 and the u minus 2. So going through our multiplications here, you do need to distribute, start to combine some like terms, but this would be our overall fraction in the end. Remember, you don't have to try to factor this. Maybe it might be factorable, but you will not be able to cancel anything out because we did all the canceling out in our first step. Now in our second one, we want to get rid of the square roots in our denominator, so we need to rationalize that. That's the particular phrase for what this is called. We are rationalizing specifically the denominator of our fraction. We're getting rid of those square roots. So we need to multiply by the conjugate of our denominator. That's simply changing the operation. So in this case, it would go from a plus to a minus. Going through and multiplying, remember, don't worry about the numerators. Okay, we want square roots, or we can have square roots in our numerators, so no issue there. But we could use the little shortcut to help us get rid of the square roots in our denominator. So we could take our first pieces, multiply those together, take our second pieces, multiply those together down here, and simplify our way down. Now what's nice about this one is once we get to this denominator, we could distribute in the negative, but then we would have an x minus x, which would be no variables left, and then a 3 minus 2, which is just 1, but anything over 1 is just itself. So all we're really left with is the numerator in this case. Hopefully we did really well with those two. I know these can get tricky. It's a lot of writing. It's a lot of keeping things organized and neat. So try to do that, but if you do need help on any of these, don't be afraid to ask. So good luck on the practice and the application, and most of all, that mastery check.